In this video, we'll explore how a LACT unit works and why it's important for oil and gas producers. After initial drilling and production, the resources are separated, and custody or ownership of the oil is typically transferred from an upstream producer to a midstream oil and gas company for storage or transportation. LACT stands for Lease Automatic Custody Transfer. A LACT unit is a piece of oil and gas equipment used to sample and measure oil so it can be transferred from one company to another. The pump draws oil from the storage tank into the LACT unit. The levels of BS&W, or basic sediment in water, is read by a sensor and a probe in the flow stream, which is then communicated to a control panel. The BS&W Monitor records representative samples of the oil and the percentage of water. Often, these monitors will also read the temperature of the oil, which can affect the measurements. The oil travels through an air eliminator, which removes gas or air in the pipe without allowing the liquid to escape. This air can cause inaccurate metering if not removed. An inlet static mixer emulsifies the liquid so that an accurate volume measurement can be taken. There is natural separation when the fluid is flowing through a straight pipe, which can lead to certain kinds of meters reading only one of the fluid phases and not both. The BS&W Monitor also controls a three-way valve to direct the oil to its appropriate destination. If the sediment and water amounts are too high, the diverter valve will route the oil to a separate bad oil tank to allow natural separation to occur before it is rerouted to the LACT unit again. Bypass lines can direct the oil to the beginning of the separation process or a standalone heated vessel to remove high levels of BS&W. If the sediment and water amounts are acceptable, the three-way diverter valve will open and send the oil to a flow meter to have the volume measured. The type of meter is determined by the maximum mass and volumetric flow rate. On this location, a Coriolis meter is being used. Using motion mechanics, the meter splits the processed fluid into two coils oscillating in opposite directions. Voltage is generated, sine waves are created, and the time delay in motion is proportional to the mass flow rate. Located after the flow meter are block and bleed valves and proving connections. This is where a proving meter can be connected to periodically test the accuracy of the metering system. The oil moves through a back pressure valve, which holds pressure against the LACT unit. This is typically a spring-loaded back pressure valve because it requires no supply gas to operate. A check valve prevents the backflow of metered fluid from the pipeline back to the LACT unit. The good oil runs through the primary LACT unit into an external midstream pipeline. On this location, it is discharged at 45 psi. It is then directed to a progressive cavity pump, which will increase the pressure to over 600 psi. This will provide enough pressure for the oil to continue through the pipeline to other booster stations and destinations. This is the secondary LACT unit on location. From this unit, the good oil moves to a flex hose for connection to a truck to pull the oil off the tanks. Bypass valves allow operators to direct the oil through the unit when a truck is prepared. Some people refer to the LACT unit as the cash register of the oil field because producers use it to meter and calculate payments when selling oil. It's important to remember LACT units not only measure the quantity of the product being transferred, but also its quality, which is the amount of sediment and water in the oil. Drop any questions below, or to learn how you and your team can access more in-depth oil and gas training content, or to schedule training over related topics, contact an expert at your local Camry store or authorized distributor.